Okay, so we review about 4 types of discontinuity. First one is removable when you have an open hole. Okay, the second one is a jump. So like the function is here and then jump here. What kind of function is this? What kind of function is this? Piecewise function. Very good, very good, very good. So then asymptote is when there's asymptote that they never across. Okay, this is also discontinuity. Remember, continuous function is when you're gonna draw without lifting the pen. So think about it this. Let's say one more. Let's one more. Oh, okay. Oscillating. Is it how you say it? Oscillating with discontinuity. This is not really popular, but also one of the discontinuity.
Is it going to be on the AP test?
Yeah, they will. They also include it. So okay. Oh no, I just reviewed unit 1. Just maybe write somewhere you want it. We're going to start unit 2 now. Yeah. What day today? 8. So today we review derivative basics.
No, a lot of people left. It was mostly like we stayed back. It was like me and my
Okay, can I erase this? Yeah? You know this, right? I just asked you. So yeah, this one also on will be on the SN. On the ABSN. Derivative. Easy, right? Basic. You know something like basic foundation, you're gonna scare. Because you don't know it, you're gonna feel like, oh, I don't know the basic. No, it's okay. What is the derivative of this? Easy. X to the power n. This. X derivative of x to the power n is. Oh, that you don't see the n.
Yeah, there was something else.
Yeah.
Yeah, that's perfect. Missed that's too little. Yeah,
That's too little. That's good.
I have glasses from Sharpie. You need to make it bigger.
N x minus n
What is this?
over dx.
Ah.
Oh, that's perfect, Miss.
That perfect? Okay. One lesson gonna take you 5 hours.
Can you write everything like
You
that?
write and erase, write and erase. What is it equal then?
It is n
N x to the power n minus 1. See, now I need to erase it.
I was close to
Good?
Yeah,
Thanks,
yeah,
Mr.
perfect.
So n x to the power n minus 1. Easy. Doesn't matter what the parenthesis, but just to put there so you know. X minus 1 only apply to the x. Okay? How about this?
I know. Ex.
Yes, that's it. That's the good one. Integral, derivative, they're both the same. Product rule. U times V derivative is, yeah, Jay.
Wait, what is the?
U prime.
Oh.
You can go U prime.
U prime times
V.
plus v prime times v.
Yeah. So, or I write it like this: U V prime. Okay. So UV and UV, but the first one you're gonna take the derivative of the first term And the second one, you're gonna take the derivative of the second term. Okay? Which one?
The prime, just the prime.
This one? Just a prime. Just a, yeah. Derivative. That's the derivative, right? Short way you write the derivative. How about quotient rule? Yasmin. I never. I actually I don't know Yasmin voice. Have you ever talked?
Yeah.
Oh yeah. Okay. Oh, now to say yeah. I can heard it now. Let's go. Let's go. U prime. Yeah. Minus. V prime. So they kind of similar, right? But one plus, one minus. Okay, and then over V squared. Okay. So good job. That's the quotient rule. Do you know how about U, V, and W?
Wow.
Huh?
No, I don't.
W. The three term, like three term. But if you have three term, you know how to find it? Huh?
Pretty?
What? How about take 1 minute to think about this?
I don't need a man.
Fine, Valerie, yes. Basic thinking. If you have two, you're gonna take the just each derivative of each, right? You have three, same thing. You're gonna take the derivative of each,
Yay!
right?
Wait, is that it? Because that's all I got.
No, I saw you move the letter to the front, but my way I just like to write to move the prime.
That's how I did it.
It works still same
Mister,
thing.
that's how I did it.
Same thing. Yeah, that's why I said you. Yeah, exactly the same. So I say it's on the wall because you can think like this. You can think like this. You can think like you take the derivative of this and this,
Wait, you should write that down.
right? You can think like you take the derivative of these two things. I combine these two together. So I take the derivative of each one. So I'm gonna have this plus this. Yeah, do you agree? I just combine these two UV together. So now I can using this product rule. And then this one I'm gonna use the product rule again, and then I get this one. Okay? Not hard. It's just so you know you can just take the derivative of each one. Okay, so let's go to the real problem. This is a review derivative of the position. Okay. Oh, you know, oh yes, man. Sure. The position. How did you get it? How do you find the velocity? The derivative. How do you find the acceleration? Okay, twice, right? Second derivative. That's good. Okay.
No.
I think that's all you need to know. T cubed minus 6. Okay, let's. Easy. Super easy. Find velocity. Uh,
I'm done.
yeah, easy, right?
What?
Yeah, you can get this, bro. Don't worry. Actually,
You can do along the, you can answer them as well at the same time. Easy.
When is a particle of rest?
At rest.
So when you
Yeah. Okay.
I
5 seconds. Velocity function, easy. Emily, what is velocity function?
You have to take the derivative.
Very good. Then what did you get?
I got 3t squared
Minus.
12t plus
Okay. Good. Right.
See, that's what I got.
You all got this one? Yeah, for sure. Okay. Find velocity at T2 and T4. Easy. You're gonna plug it in, right? So what did you get for the T2? Negative?
-3.
-3. What did you get for the V4? 9. Good. Easy. Okay. Let me see, is it correct? -3. Yeah, 9. Make sure to do units. Okay, just to be safe, you know, when you do the free response AB, they actually check the units. So make sure you also write the units, so in case, okay? Now, when is the particle at rest? What does it mean when a particle is at rest? When, which one is zero? Position zero, acceleration zero, or velocity zero? The velocity is zero, right? Velocity is zero, that's mean at rest. So V equal to zero. Okay? So you let this whole thing right here equal to zero. So when V of t equal to zero, how do you solve this? Factoring back to the hand. We have been done a lot of factoring. How do you solve this? Third out of 3. Factor the 3 out. You have t squared minus 4t plus 3. What next? Do you remember how to factor this? Yeah? 2 number multiply to get 3. 2 number multiply to 3. 3 and 1. 1 and 3. So you have 1 and you have 3. What is the side 1 and side 3? So that you're going to get -4. They're both negative. Okay? So now if I want this one to be 0, what is the solution then? Solution is t equal to? And t equal to? 3. That's it. Okay? Easy. The next one, when is the particle moving forward? So remember position. They're telling you where is the position. Okay? Velocity not only tell you the direction, the how fast it is, but also telling you the direction. Okay? Okay. Remember, velocity also tell you the direction. So let's say you stay right here. This is my position. I'm going to this position, but I'm going forward. My velocity is going to be positive. But if I'm going to start going backward, my velocity is going to be negative. So remember, velocity also indicate the direction. Okay, also direction, not just the speed, but also direction. So when the particle moving forward, that means when the velocity is positive. When the v is positive. Okay. Now, how do you know when the v is positive? There, then you need to do the sign chart. That's right. Okay. Which one is going to be 0? Equal to 1, right? T equal to 1 and t equal to 3. That's going to be 0. This one is going to go to infinity. This one is going to go to negative infinity. Oh yeah, that's right. Good. Good, yes. So, okay, how do you do the sign chart? Or you plug it in? Another way you can do that is you don't need to plug it in. You only plug it in when you have really complicated function, like have top, bottom, and something else. This one is very basic. I mean, not basic, but very simple function. You look at the coefficient. What is the coefficient? What is the leading coefficient? Look at what is the leading coefficient? 3. Is it positive or negative?
Positive.
On the very right, it's going to be positive. Yeah. And then whenever you pass over the critical point, they're gonna flip it. They're gonna flip the sign. So negative, positive. So you don't need to plug in a number. You only plug in a number when you have really complicated function. Okay. This one is you can tell the leading coefficient. Okay. So you can write a note here based on the leading coefficient LC. That's faster. Okay. Faster than you plug it in. Because sometimes you plug it in, you got it wrong. That's going to be messed up. Yeah. Of the one you want to do the sign chart. Not this. This one will do the same thing anyway. But you should be look at the original one. That's right. Look at the original one. Okay. Then what is your answer then? Moving forward during the time. First 0 to 1 and 3 to infinity. Okay. What is the parenthesis bracket? 0. Bracket or parenthesis? Bracket. Okay. 1. They're gonna be 0 anyway. And then 3. What's in between? Union. U. Okay. You know, no, actually no, not 1 and 3. Because at 1 and 3 they're going to be at rest. So not include that one, not include that. Yeah. Because 1 and 3 they're going to be stopped, right? That's right. Yeah. That's why when the particle is going to be at rest. So you don't include 1 and 3. Yes, don't include 1 and 3. Now this one I think we need to talk. Distance travel. Do you remember how to find it? What is the another one that's close to the distance travel? Same concept. So distance travel is the total you're gonna travel, right? Let's say I'm at 0 right now. I'm at 0. I'm gonna walk 1, 2, 3, and then I start walking back 1, 2, 3. What is my distance travel? Total distance travel 6. But what is there's another, let's say going to be 0 because I go back and forth. It's same thing. A star and the end at the same point. What is it called? Displacement. Okay. Very good. Let's record that. So displacement is the end minus the star. Okay. Like the final destination minus the initial destination. So it's going to be what? Integral of from A to B, VT dt. Okay, that's the Because when you take the derivative, you're gonna get the. Why does it make sense? Because when you take the derivative of the velocity, what did you get? You get a position, right? The fundamental theorem of the calculus saying that this is equal to what? Equal to SB minus SA. This is, you need to make sense of the formula so you can memorize it. Like you don't need to like just by heart. Memorize by heart. But when you understand it, you will know it for sure. You're not gonna make a mistake. Okay? The fundamental theorem of calculus saying that when you take the integral, it's going to be the integral of the limits. Very simple. But because the reason why this is gonna give you the displacements, because when you're taking the derivative of this, when you're taking the integral of this, of the velocity, you're gonna get a position. So SB minus SA, that's the end minus the start, right? Final destination minus the initial destination. So this displacement, that's different. Now this one they're asking you about the total distance travel. Let me just write here so everyone can see. Total distance travel. How do you find this?
Plug in 5.
No, I mean what is the formula? Very similar. You just need to do one thing, very similar to this. Absolute value, very good. Remember displacement, they don't take the absolute value because when you go down, when you go backward, you're going to be negative. They cancel out. But when, the only thing you need to do is when you're taking the absolute value. That means you don't take the negative value. Okay? You don't want a negative value. So they all count. I walk 3 steps, I count 3. I walk back 3 steps, but because I take the absolute value, I walk backward, but I still count positive. So 3 plus another 3 is going to be 6. So that's why the absolute value is going to give you the total distance travel. Okay. So for this problem right here, you're going to take from where to where? They're asking for how many seconds? 5 seconds. So from 0 to 5. VT. Is that correct? Why not? You need to have absolute value because they're asking about the total distance travel. Okay? So what do you have? Okay, how long you still have? Okay, one last question. Maybe 4 minutes. Find the acceleration at 4. Find the acceleration at 4. A4 is?
You just take that. Second derivative. No?
What is A4? Taking the derivative of? Right, so what do we have? Let's do together. So 6t minus 12. And you look at 4, what do you have? 24 minus 12, which is 12. Okay? Now the last one going to be is the particle speeding up or slowing down? At t equal to 4. At t equal to 4.
Slowing down.
It's speeding up.
Speeding up or slowing down when t equal to 4?
It's speeding up because the acceleration.
How do you know it's speeding up?
Because the acceleration is positive, no?
No, it has to be
Huh?
same sign.
Exactly. Do you remember that one? Okay, let's write down if you forgot. They speeding up when? Speeding up when? VT and AT, same sign. Right, same sign. Same sign means when you multiply them, they're going to be larger than 0. Okay? And then slow down when V and A, different sign. Okay? So,
It's speeding up.
speeding up, right? VT is positive, right? Did we find it one already?
Yeah.
VT is positive and AT we just found it also positive, so this is going to be speeding up. That's it. Oh, good, we make it.